Okay, let's graph a couple of ellipses. So these are still focused where the vertices, where the center of the ellipse is the origin. And I like to do more examples here because if we can get the roots of it at the origin, we just need to take our time when we have the center somewhere else. So when we look at this example, let's just put a little dot for our center there. And what we have noticed from these prior problems are that when you have the larger number in the denominator, then that's going to be denoting the major axis. So the major axis, since the 16 is under the x, the major axis is the x-axis. Okay, and then when you're really getting the vertices for that major axis, you are essentially like finding the zeros or finding the intercepts, especially for when the center's at the origin. So it's like if you were to cover this part up, ignore all this, and you were to solve for x, you would get plus or minus 4, because you would multiply 16 to both sides and then get the plus or minus 4. So that's basically how we know that the vertices are going to be here at negative 4, 0, 1, 2, 3, 4, and here at 4, 0. The units, the vertices for the minor axis are going to be found by like covering all this up and solving for y, and in which case you would get y squared equals 8, and when you square root both sides you're going to get 2 root 2, and so the square root of 8 is the same as like 2.8, so close to 3. So let's just delete all that part though. So then 2.3 approximately, let's make it there, and then negative 2.3, and we have our ellipse. There you go. It's hard to draw on this pad, but sometimes if the vertices are close to forming a circle, I'll just sometimes just write ellipse so that we know that the distance from the center to the vertices are not the same from the center to the vertices on the minor axis. So we state the vertices. Let's just do that right here. Vertices are going to be, in this case, plus or minus 4, 0. And then the foci, we want to find the foci. And so we still want to use that equation b squared equals a squared minus c squared. And so we know our b and our a in this case, or our b squared and our a squared, so that is going to allow us to solve for c squared. So the b squared is 8, the a squared is 16. So keep in mind as well that the a is always the vertices that are on the major axis. And so this will be minus c squared. When we solve for c squared, we'll end up getting negative 8 equals negative c squared, or c equals the same plus or minus 2 root 2, or approximately the plus or minus 2.3. So the ordered pairs for the foci are really going to be plus or minus 2 root 2, comma 0. And then we stated what the major axis is at the beginning. Now, when we look at this next part, it's written in a slightly different form. And one thing that you've probably noticed is that with that equation of the ellipse, it always ended in equal 1. And so we can put it in that form by dividing everything by 36. So we'll end up with x squared over 4 plus y squared over 9 equaling 1. So now, because the larger number in the denominator is under y, the major axis is the y-axis. I should just be writing MA for major axis. But it's the y-axis. And so when it shifts, I'll always just do that major axis first. And so again, if you find the intercepts cover all this up, you're going to solve for y squared over 9 equals 1 and getting y equals plus or minus 3. So 0, 3, and then 0, negative 3. And to find the points on the minor axis, just cover all this y squared minus 9 up and solve for x, and you would get negative 2 and 2. So negative 2, 0, and 2, 0. Centers at the origin, and so here's our ellipse. That last part. Alright, and so we also want to let's go ahead and state the vertices again. Alright, so I just went ahead and wrote it out. The vertices are going to be 0, positive 3, 0, negative 3. The foci we still have to find by using the equation b squared equals a squared minus c squared. And so just be careful with how things switched. So you'll know you've done something wrong when you'll have a negative number inside the square root when you were to solve for the foci. So that the b squared is associated to the minor axis, the a squared is associated to the major axis. And so when you plug all that in, you'll get 4 equals 9 minus c squared. Subtract 9 to both sides, you get negative 5. The negatives cancel and square root both sides, giving you plus or minus. And because the major axis is now on the y-axis, the ordered pairs for the foci are 0 plus or minus square root 5. Alright, I hope you found this video helpful, and I'll see you in the next one.